We're going to look at a second way to solve quadratics, the quadratic formula. So from the past 2 days, we've been really working on factoring. For example, like this, we said set it equal to 0. So we had x squared minus 6x plus 3 equals 0. So we said multiplies to 3, so we had 3 and 1, and nothing would multiply together to negative 6. So we said this one is not factorable. Some of you looked at this and you said, hey, but I can factor this part right here. This factors into x minus 3 times x minus 3. So you said that this is x minus 3 squared equals 6. And if you take the square root of this, we have x minus 3 equals plus or minus the square root of 6. And then we just added 3. So you had x equals plus or minus the square root of 6 plus 3. But for those of you who don't see this quite as easily and you try the factor and you can't figure it out, we're going to take a look at the quadratic formula today, which will help us. Some of you guys might remember that Pop Goes the Weasel song from last year, but a reminder, it's x equals the opposite of b plus or minus the square root b squared minus 4ac all over 2a. So when we're using the quadratic formula, same thing. It has to be set equal to 0. So we can identify our a, our b, and our c. And now we can plug it into the formula. X equals the opposite of b plus or minus the square root b squared. And you got to remember, if it's negative, it's got to be in parentheses, minus 4 times a times c all over 2a. Now, one thing you want to be careful of is you don't want to just type this all straight into your calculator. If you use the fraction key, you'll be all right, and I'll show you that. But I usually tell people simplify it first by simplifying what's underneath that square root symbol. Because then you don't have to type quite as many things into the calculator. So let's see if this is going to come up here. So what's underneath our calculator, or excuse me, the square root symbol? We had negative 3 squared minus 4 times 2 times negative 7. So we have the square root of 65. So x equals 3 plus or minus the square root of 65 over 4. And let's see on this calculator, if we were to type that in 3, you can't put plus or minus, so the square root of negative 3 squared minus 4 times 2 times negative 7 all over 2 times 2. And it gives you that as a decimal. So if you wanted the exact answer, it would be here. So this next one, we have to set equal to 0 first. And again, I usually leave the a value positive. So we have x equals the opposite of b plus or minus the square root b squared minus 4 times 3 times negative 6 all over 2 times 3. So again, I'm going to plug in what's underneath that square root symbol first. So negative 7 squared b squared minus 4 times 3 times negative 6. And we have 121. Now some of you might notice, well, we can actually take the square root of 121. So we can find our two answers without having to round at all. We have 7 plus 11 divided by 6, but then we have 7 minus 11 over 6. So 18 over 6 is 3, negative 4 over 6, or negative 2/3. So we can find our two answers there. If it's not a perfect square, then you can just leave it with that square root thing. Now the second thing we're going to talk about today is the discriminant, that value that's underneath that square root symbol, the b squared minus 4ac. So we're talking about this business right here. What's underneath there? And now the discriminant tells us something. If it's bigger than 0, there's 2 real solutions. Because we can do a plus what's underneath and minus. So it ends up crossing the axis twice. If it equals 0, there's only one real solution. Because when you think about it, then we have negative b plus or minus the square root of 0 all over 2a. So that doesn't matter. So we don't have the plus or minus, so it's just 1. And that's where it's called that double root. It just hits it once. If it's less than 0, we have 2 imaginary. And we're not going to get too far into those imaginary ones, but they always come in what's called conjugate pairs, like 2 minus 3i and 2 plus 3i. It always comes with that minus and plus. So determine the discriminant and the nature of its roots. So we have to figure out our b squared minus 4ac. So we have 6 squared minus 4 times 9 times 1. So 36 minus 36 is 0. So it has one real solution. Now this one, well, let's see. I'm going to write it with our fraction looking something like this. We have to get that x out of the denominator and set it equal to 0. So we'll multiply by x. So we have 3x squared minus 5x equals 4. Set it equal to 0. And then we'll find our b squared minus 4ac. So we have negative 5 squared minus 4 times 3 times negative 4. So let's see, 25 plus 48, is that? 16 times 3. Yep. And I know that's going to be positive, so this one has 2 real. Now let's see if we can go the other way here. Find the value in which it has 2 real roots. So that means it has to be greater than 0. So our b squared minus 4ac has to be greater than 0. So we have negative k squared minus 4 times 2 times 3 has to be greater than 0. Well, negative k squared is really just k squared. Let's see, minus 24 has to be greater than 0. Alright, so we can add 24. So we have k squared is greater than 24. Now, we have these 2 answers here because we have k is greater than, but we have plus and minus the square root of 24. So it can either be k can be greater than the square root of 24. So when you think of these values, that's like 5, 6, 7, but it could be a negative value too. So we are going to say k can be less than negative square root of 24. Because when you think about values that work, if you were to put this on a number line, here's the square root of 24. So that means values like 5, 6, and 7 work, which means if you're going to square a negative, it would be negative 5, negative 6, and negative 7. So when you're solving the square root sign, when you have that negative, you have to switch it to a less than sign, just because you want those negative values, those really small negative values, or the bigger values when they're positive. So let's see here. Pause and see if you can try these. One repeated root, so that means it equals 0. So we want b squared minus 4ac to equal 0. So we have negative 2k squared minus 4 times 3 times 5 equals 0. So we have 4k squared minus 60 equals 0. So 4k squared equals 60. So k squared equals 15. So k equals plus or minus the square root of 15. And then it has no real roots. So that means b squared minus 4ac has to be less than 0. So we have negative 8 squared minus 4 times 3k times 1 has to be less than 0. So 64 minus 12k is less than 0. So negative 12k is less than negative 64. And then when we divide by a negative, you have to remember we have to switch the sign. So k is greater than 64/12. So k is greater than, let's see, 32/6. Cut it in half again. K is greater than 16/3. Just a second, I need to, why won't it go over here? Oh, that's why.
Do you have scissors?